So, in this lecture, I am talking about the BORN approximation in scattering problem. And in the first part, I will talk about integral form of Schrodinger equation and evaluation of green functions. And in the next lecture, I will talk about second part of it, that is the first BORN approximation. Then I will start talking about the BORN series. So let us start with the integral form of Schrodinger wave equation. Let us try to derive it. So consider time independent Schrodinger equation. That is minus h cross square by 2m del square psi plus b psi is equal to e psi. And let me call it as equation number 1. And this equation can be simplified as del square psi minus 2mh cross square v psi is equal to minus 2m over h cross square e psi. Basically what I did, I multiplied with minus 2m over h cross square both sides, so it will cancel out here and this will become like this. And let me simplify it, bringing this towards this side and this towards that side. Then it is del square psi plus 2m over h cross square e psi is equal to 2m over h cross square v psi. And let me call this term as k square, and let me call this as q. This whole part as q, and this q is basically a function of psi because this q is incorporated into it, right? So that's what I have assumed. That means this k square is equal to 2me over h cross square, and q psi or q, simply it is 2m over h cross square v psi. And if I use these here, then this is equal to del square plus k square psi is equal to q, and q is a function of psi. So what is it? This is a basically inhomogeneous differential equation. This is inhomogeneous differential equation. This is inhomogeneous differential equation. Now, such inhomogeneous differential equation, they can be solved using green function. In such equations can be solved using green function approach. For the briefing of this green function, you can follow book by Yarfkan, Mathematical Physics by Yarfkan. So let us try to understand that how green functions help us to solve such a differential equation. So let GR be the green function, and it is defined in such a manner such that del square plus k square, this part in place of psi, if it is operated with green function, means this green function is chosen in such a manner. If this is replaced this wave function with gr green function, then it will become a delta function, right? So it's a delta function. So we can define the green function in such a manner, and if it is expressed in such a manner, then what about psi? Then psi can be expressed in terms of green function or in the form of integral. Then means it is defined in such a manner, then this psi, this can be expressed in the form of a integral containing green function, right? So psi r, it must be equal to gr minus r naught, it is qr naught d cube r naught, and let me call this as equation number 4. So basically this completes the definition of green function. Thus the wave function thus wave function psi r defined by equation 4 satisfies the Schrodinger equation. Schrodinger equation, that is del square plus k square, that is psi r, must be equal to qr, right? So the psi function which we have defined in equation number 4 using green function, and that must satisfy this equation. We can also check it. If we want to check, then we can check, otherwise there is no need to check it out. So let us try to check it. So this is not necessary in this, but we can confirm this idea. Okay, so let us consider differential equation. So that means del square plus k square, it is psi r, is equal to, let us put the value of psi r here from equation number 4, and it must comes out to be equal to qr, right? So I have chosen it and substituting the value of this wave function in terms of green function, right? So this is a way that how we have taken it. But this is integral over r naught, and this del square plus q, it can be taken inside the integral. So if I take it inside the integral, it can be written like this: gr minus r naught, and it is qr naught and d cube r naught, and this is basically the delta function. This is the way we have defined it for in terms of green function. So it is del cube r minus r naught and q r naught d cube r naught, and its integral. And if I apply the definition of delta function, because then this is basically qr, right? So this is the definition of, here I have applied the definition of delta function, right? So I use that definition. The definition is that if we are having f r naught delta r minus r naught, and it is d r naught is there, its integral is always f of r, right? So this is simple property of delta function which I am using here. That means if I use the wave function defined by this equation 4, and that is in this form, So if I do this, and then it again comes out to be equal to QR. So that means we have proved this. Means the wave function which we have defined in the form of a green function, that basically satisfies this Schrodinger wave equation. Right. So let us now try to find out the green function. Right. Now our objective is to find green function for the given problem. So and the green function which we have defined in equation number 3 for that, right? So for this, what do we do? We consider green function in terms of Fourier transform. So for that, GR is basically 1 over 2 pi raised to power 3 by 2, and it is e raised to power iota SR GS and d cube S. Now del square k square GR, it can be written as del square plus k square, and it is 1 over 2 pi raised to power 3 by 2, and integral e raised to power iota S dot R GS and d cube S. And this further will become, it is 1 over 2 pi raised to power 3 by 2, and I have taken the integral del square plus k square e raised to power iota SR, and it is GS d cube S. So if I try to look at this part, and it is del square e raised to power iota S dot R, and let us try to look at it, that how it will become. So let us proceed as follows. So it is del square e raised to power iota SR. It's like d square over dr square e raised to power iota SR. It's like this. So it can be written as d over dr into d over dr e raised to power iota SR. So it's like then it is d upon dr is e raised to power iota SR, and again its differential. So if I take its differential, then it's like iota S into iota S e raised to power iota SR. So iota square and S square, and iota square is -1. Then it is minus S square e raised to power iota SR, right? So I will use this value here. So if I use this here, then it will become that's equal to 1 over 2 pi raised to power 3 by 2 integral minus S square plus k square, and this part will remain as it is. So iota SR, and it's GS and d cube S. Now I will recall a very important theorem that is known as Plancherel theorem. Let us recall Plancherel's theorem, and if we recall it, then if delta x is defined as 1 over 2 pi e raised to power iota kx, its integral over dk, right? Then for 3 dimension it is delta q bar is equal to 1 over 2 pi raised to power 3 and e raised to power iota sr. This is for our 3-dimensional problem which we have taken, and it is d cube s. So it is del square plus k square. It's a gr, and this is the Plancherel theorem, and this is one thing which you have obtained. This is like this, and another important thing which we have to recall, that this is del square plus k square into gr is equal to del cube r. That's a definition of Green function. So if it is the definition of Green function, that means this whole of the part can be equated to the delta function. This is equated with the delta function, and I can use the value of delta function using this. So if I do this, then how things can be written? Things can be written as this 1 over 2 pi raised to power 3 by 2 integral minus s square plus k square e raised to power iota sr gs and d cube s, and which is equal to delta cube r using this identity. But delta function is equal to this, so it is equal to 1 over 2 pi raised to power 3 e raised to power iota sr d cube s, its integral. This is from Plancherel theorem, right? So I have equated these things. So if I compare these two sides, so then, and 1 over 2 pi raised to power 3 can be written as 1 over 2 pi raised to power 3 by 2 into 1 over 2 pi raised to power 3 by 2, and if I use this identity here, then this gs comes out to be, because I want to calculate this and this, so if I use these, then this part is equal to or I can say that if I compare these two sides, then gs comes out to be 1 over 2 pi raised to power 3 by 2 into, or I can say that it's over k square minus s square, right? This I have written in this way, so 1 upon. So this is the value of gs which I can calculate by comparing these results. So this is the value of gs which we have obtained. So therefore this Green function can be written as, therefore Green function can be written as this gr is equal to 1 over 2 pi raised to power 3 by 2 e raised to power iota sr, it is gs and d cube s, and I substituted the value of gs from the equation which I have obtained, and that is the equation number 6. And let me call this as equation number 5. It means Planck-Joule theorem. So it is gs and d cube s, and the value of the gs can be obtained from equation 6, and it will be equal to 1 over 2 pi raised to power 3 by 2 e raised to power iota sr, and 1 over 2 pi raised to power 3 by 2, it is k square minus s square, and it is d cube s which I have obtained, right? And if I do this, then it is d cube s, and let me call this as okay, let me simplify it. Both will put together. If I put these together, then it is 2 pi raised to power 3 and integral iota sr and 1 over k square minus s square, it is d cube s. So it is Green function. And let me call this as equation number 7. Now we have to evaluate this integral, so that we have actual form of Green function. So to evaluate this integral, let us choose that r is fixed. So say it is coordinate axis, and here this r is fixed, this is r axis and this is fixed axis, and here somewhere it is s vector, and this is making an angle theta. This is r vector, this is angle theta, and if I draw this perpendicular and this is angle phi, so we have chosen it such a manner. So that means I have chosen spherical coordinates s, theta and phi with polar axis along r axis. Thus s dot r is equal to sr cos of theta. Now gr is equal to 1 over 2 pi q integral e raised to power iota sr and 1 over k square minus s square and d cube s. That's what I have taken. What is this d cube s? D cube s is basically the volume element. It's a volume element and is equal to s square sine theta, d theta and d phi. It's a volume element expressed in terms of spherical polar coordinates. Spherical polar coordinates. So therefore, if we use this here, then gr can be written as this gr is equal to 1 over 2 pi q integral e raised to power sr cos theta 1 over k square minus s square and it is s square sine theta ds d theta and d phi. Sorry, ds will also be there. And this integral is basically representing triple integral. So therefore, let me write down this integral in other way, 2 pi raised to power 3, and its integral 0 to 2 pi d phi and integral 0 to infinity. It is s square k square minus s square ds and integral from 0 to pi e raised to power iota s r cos theta sin theta d theta, and it is fixed, so its value comes out to be 2 pi directly. So it is 2 pi over 2 pi raised to power 3, and its integral from 0 to infinity, and s square over k square minus s square ds, and then its integral iota s r cos theta sin theta d theta, and it is 0 to pi. So let me first of all try to solve this integral. The value of this integral comes out to be, its value is equal to, and this 2 pi will cancel out and it's 2, so it is 1 over 2 pi square, and it is 1 by 2, and integral minus infinity to plus infinity. This I have simplified this 0 to infinity. I have converted into from minus infinity to infinity, and this put here 1 by 2, and it is s square k square minus s square ds, and its value will be, the value of this integral comes out to be 2 sine sr over sr, right? So it is, this 2 will cancel out with it, and this s with this s, so it is 1 over 4 pi square, and r can be taken outside because it's integral over s, so it is integral minus infinity to plus infinity s sine sr over k square minus s square ds. That's what I am getting here, right? But let me try to understand that what this, how this integral comes out to be equal to this integral. So for this, let us proceed as follows. So consider the integral 0 to infinity e raised to power iota s r cos theta sin theta d theta. So here let cos theta is equal to t, and sorry, it's not infinity but it is 0 to pi. So when the value of cos will be 0 and theta will be 0, then the value of will be equal to, so theta is equal to 0, t comes out to be 1, and theta is equal to pi, t will be equal to minus 1. So this integral will become minus plus 1 to minus 1, and here it is, if I use this, then using this it is minus sine theta d theta is equal to minus dt. So putting all these here, so e raised to power and negative sign will be there, minus e raised to power iota srt into dt, and if I solve this integral, then this integral comes out to be minus e raised to power minus, sorry, e raised to power iota srt over iota sr, and limit varies from plus 1 to minus 1. So it is like this, and let me simplify this. So if I simplify it, then it is minus e raised to power iota sr. The value of t will be, upper limit is -1. So if I put -1 here, then it is negative over iota sr, upper limit minus lower limit. So minus e raised to power plus iota sr over iota sr. So I have simplified it, and this part will be equal to, so it is plus, so it is e raised to power plus iota s, I put it here and this towards that side, and minus iota sr divided by iota sr. So if I multiply it by 2 and it with 2, then this modifies to 2 e raised to power plus iota sr minus e raised to power minus iota sr whole divided by 2 iota and 1 over sr, and the value of this will be sine sr. So it is 2 sine sr over sr, right? So that's what I have used here. So let me go back to again my problem. So this is the integral which I am getting. So now I want to solve this. So this is equal to 1 over 4 pi square r, and its integral minus infinity to plus infinity, and this is sine sr, and sine sr can be written as this s as it is, and this sine sr can also be written in exponential form. So in exponential form it can be written as iota sr minus iota sr divided by 2 iota. This is the value of it, and it is k square minus s square as it is, and ds. So I put its value. Now proceed as further. So this is equal to, and 1 over iota is here, and if I take it outside and this 2 also, then it is 1 over iota can be written as minus iota. So it is minus iota 8 pi square r. So both put together, and here it is minus infinity to plus infinity, and s e raised to power iota sr minus iota sr divided by what? It's divided by k square minus s square into ds, right? So it is equal to, if I put s square here and k square here, then this negative will become positive. So it is positive iota 8 pi square r, and integral minus infinity to infinity plus infinity, it is s e raised to power iota sr minus iota sr whole divided by s square minus k square into ds, right? So this s square minus k square and negative taken from here, and that makes this negative sign positive. And let me try to simplify this integral. So it is iota over 8 pi square r, and integral minus infinity to plus infinity. So it is s e raised to power iota sr over s minus k and s plus k. I have splitted this into ds minus infinity to plus infinity. It is s e raised to power minus iota sr whole divided by s minus k s plus k into ds, and let me call this as integral I1 and this as integral I2. So if I do this, then what do I do? It is basically written as I over 8 pi square r integral I1 minus integral I2, and let me try to solve these integrals I1 and I2 separately. So this integral I1 can be written as, it's a contour integral s e raised to power iota sr divided by s plus k into 1 over s minus k ds, and I2 comes out to be s e raised to power minus iota sr divided by s minus k 1 over s plus k. It's a ds, and they are standard integral, and using contour integration it comes out to be iota pi e raised to power plus iota kr, it's iota kr, and this integral will be minus iota pi e raised to power plus iota ki. These are the standard integrals. You can use these results directly, or you can solve these integrals using contour integration. So now I will put these two values here in this equation. Therefore, green function gr will become, this gr is equal to iota over 8 pi square r, the value of integral I1 minus integral I2, it is equal to iota over 8 pi square r. Its value is iota pi e raised to power iota kr minus iota pi e raised to power iota kr, and it is equal to iota over 8 pi square r to iota pi e raised to power iota kr, because both will become identical, minus minus will become positive, so things will cancel out, and iota will become iota square, it's minus, so it is 1 over 4 pi r, because this will cancel out with it, and it will be equal to this pi with it, so it so minus 1 over 4 pi r e raised to power iota kr. So hence this green function, we can evaluate it as this gr is equal to e raised to power iota kr over 4 pi r with negative sign. This is the value of the green function which we can use directly. So you can derive this, or depending upon problem to problem, you can use it directly, or you can derive this green function. So this is the green function. Green's function for equation del square plus k square gr is equal to del cube r, and this equation is also known as Helmholtz equation. Helmholtz equation. So now using this value of green function in equation 4, and what is equation 4? Let me recall equation 4. Our equation 4 is like this. it is psi r is equal to integral g r minus r naught. It is q r naught and d cube r naught. So as gr I have defined as minus e raised to power iota k r over 4 pi r. So therefore gr minus r naught can be written as minus e raised to power iota r minus r naught. It's mod upon 4 pi r minus r naught. It's mod. So if I put it here, then it will be equal to its integral then this wave function will become psi naught r plus integral minus e raised to power iota k r minus r naught mod upon 4 pi r minus r naught mod. It's the value of this, and we have also defined q as that q we have defined as 2m over h cross square v psi in the beginning. So therefore at r naught I can define it as it is 2m over h cross square v r naught and psi r naught, and this d cube r naught as it is. So this can be written as psi naught r minus m over 2 pi h cross square, because this 2 will cancel out with it. So 2 pi h cross square as it is, and this m, and integral e raised to power iota k r minus r naught integral r minus r naught mod, sorry, it's not integral but r minus r naught mod divided by r minus r naught mod. It is b r naught and psi r naught and d cube r naught. And this wave function, we have wave function is the solution of the Schrodinger wave equation, and it is in the integral form. So this equation is basically integral form of Schrodinger equation. And here the psi naught, it satisfies the free particle Schrodinger equation, that is psi square del square plus k square into psi naught must be equal to 0. So the solution of this equation will give the value of this part, right? So this is the integral form of Schrodinger wave equation. So that's all for this lecture.